Hello, and welcome to my video presentation on tidal power. To start my presentation, I'll first give a brief introduction on what tidal power is. Then I will discuss the design of the tidal current turbine generator. After this, I will talk about the process of harnessing tidal energy. Lastly, I'll talk about the challenges and benefits of tidal power. So, what is tidal power? Tidal power is a form of hydropower that converts the energy of tidal currents into electricity. It's a clean and renewable source of energy which is becoming increasingly more demanding these days. Lots of research has gone on tidal power, and people have tried to use tides as a source of power for a long time. However, it wasn't until the late 1950s when technological breakthroughs allowed tidal power to be used on a broader scale. So, the tidal current turbine generator is a device used in hydroelectric plants to harness energy from marine current. In the next part of this presentation, I will discuss the different types of tidal turbine designs and their parameters. The first design is the horizontal axial turbine. In this design, the rotational axis of the rotor is parallel to the water surface and to the incoming water stream. Meanwhile, the vertical axial turbine is vertical to the water surface and perpendicular to the incoming stream. Another design is the crossflow. In this design, the rotational axis of the rotor is parallel to the water surface but orthogonal to the incoming water stream. The last design is the venturi. The venturi uses an accelerated water flow caused from a choke system. This creates a pressure gradient leading into a turbine. This slide shows all the various designs that I've just mentioned. Since most tidal power plants use the axial design, I'll mainly focus on them. This is because of their higher output efficiency. Now, there are several ways they can be designed based on their parameters. The first way is based off their directionality. You have to account for the fact that you must design the turbine to operate both during the flood and the ebb tides of the cycle. This will be explained in more detail further down. The next are the various arrangements you can make. Now here I've mentioned three. There's the floating surface mounted, the near surface mounted, and the seabed mounted. In the previous slide, we can see that some of these are along the seabed, and some of these are near the surface. Now there's various reasons for that, and most of these reasons occur from limitations that arise due to technical factors, such as power capacity generation and instrumentation. Also, they can occur for other reasons, such as fishing and recreational boating. Now in this graph, this is taken from a survey where utility companies that use tidal power were asked, how are their turbines placed? From this information, we can see that most time they are placed at the seabed. Another thing to notice from this graph is that not all tidal power plants use the ocean alone to extract their power. Some of them have combined applications where they combine river flow with a tidal current. So, in order to fully understand how energy is extracted from tides, certain properties and processes of an axial turbine generator need to be analyzed. These include choosing the location for a power plant, storing the water flow, converting the energy, and distributing the energy. So when choosing a location for a power plant, one of the most important aspects is choosing a location that has high current speeds. Typically, these are 3 to 4 meters per second. While 7 to 8 meters a second would be an ideal source, it makes it almost impossible to install anything at these high water speeds. Another thing to note, when you make a tidal power plant and you install turbines or dams, this will introduce a resistance into the flow. Now away from the dam, this will cause the water level to drop and the currents to slow down. However, closer to the dam, the rapid currents will increase, and this can cause turbulence. In addition, it can cause potential damage to marine life. And typically it's seen that when tidal power plants are installed, this reduces marine life around this area by as much as 10%. So there are three major aspects when installing a tidal power plant. First is the water dam that's composed of many different turbines, each paired with electric generators. These are accompanied by hydraulic gates to control the water flow. Now, there are two different processes to make your tidal power plant work. The first is a double action process. In this process, turbines work both in water flows. So they work when the water flows through the turbines due to the current, and then again when the water flows back into the body of water. In the single action process, the gates open until the basin is full of water. Then during the ebb cycle, the turbines operate while the water flows back into the body of water. Typically, the double action process is more expensive, but it's also much more efficient and much more environmentally friendly. This is because it allows for more marine life to get through. So in this slide we can just see how a tidal power plant can operate in both ways. So converting the energy. Now this equation is actually very similar to the equation used when calculating power for wind power. You have 1/2 times your efficiency, which in a given system, usually that's max efficiency you're going to see is about 35%. This is multiplied by your water mass density, and then multiplied again by your cross flow area. Lastly, you multiply by your water velocity cubed. Now, when constructing tidal power plant generators, you can design them almost any size, whether they're from small to big, but typically for economical reasons, you want to create them bigger so that you get values in the megawatts. Distributing energy. Now, when incorporating tidal power, it's often difficult and expensive to incorporate it into the grid. The reason for this is the location of where high tides occur. Usually they're far from industrial and urban areas, and this leads to really expensive transmission lines. Now, major research is currently being done to bring this price down, and we've seen the prices drop quite substantially over the past few years, so I expect it to drop even further. Now, the last thing I want to do is talk about the challenges and benefits of tidal power. Since 70% of the Earth's surface is covered by oceans, this potentially provides a tremendous amount of potential energy. Now, some of the things I want to look at when analyzing the challenges and benefits of tidal power are I want to look at the maintenance and installation costs, as well as comparing it to other forms of energy that are already out there. So for maintenance and installation, like any marine equipment, corrosion is always a huge concern. However, nowadays we have cathodic protection, and this can often reduce the effects. It doesn't get rid of them entirely, but it definitely makes it so maintenance is required a lot less. In addition, we can use anti-fouling paints to prevent marine growth. Now, the last thing I want to do is talk about different methods to how to mount an axial turbine generator. I know I discussed earlier the different designs. There's also different designs on how we can mount them. In this diagram, we see 4 different designs. Now, our gravity-based one is typically implemented in shallow waters. Its only drawback is, in deep seas, it's almost impossible to make an anchored device at the bottom to hold the structure down. However, in deep waters, we can use a floating design. The only drawback to this design, however, is in extreme weather conditions or in strong storms, forces can act upon the anchor, and this can cause problems with the turbine. So the best solution is to use either the monopile or the pile jacket. Now, both of these use steel towers that are actually drilled into the ground, typically about 4 meters. Another major advantage of these towers is that the blade rotors can actually be raised above the surface of the water. This allows you to maintenance them or repair them a lot more easily and makes a lot of savings. Typically though, monopile and pile jackets have much higher installation costs, but overall they save you money in the long run for repair costs. So, lastly I want to compare tidal power to other forms of energy. Now, tidal power can deliver up to 4 times as much energy intensity as wind power and up to 30 times that amount of solar. Another major advantage of tidal power is that they're predictable years in advance, unlike wind and solar where usually weather can only be predicted about days or a couple of weeks at max in advance. Typically, the rotors on turbines for tidal power actually are a lot smaller than that of wind power, so they can be a lot more compact and you can get a lot more in a certain area as opposed to wind power. Also, weight's not an issue since they're all going to be placed underwater, and cheaper material can actually be used for this reason. And lastly, they are less susceptible to extreme weather conditions when compared to wind power. Usually in stormy conditions, tides do not actually change their flow very much, and this leads to a lot of savings in terms of when you have to over-engineer things. You have to always consider worst-case scenarios, and when dealing with tidal power, this is actually where a lot of money is saved. So, this is a graph showing how much output power can we expect from different forms of renewable energy. So as you can see, solar is actually quite low, and wind is pretty low too. The graph on the left shows wave power. This is actually different than the tidal current. However, waves can vary a lot more than tidal current depending on weather conditions. So that's why we see a higher typical value from the tidal current. Now, how does it compare in cost? Well, we have all these figures showing different forms of energy. While coal and gas are typically the lowest forms, they're also the ones that do the most amount of environmental damage. Nuclear, I was surprised to find, was quite expensive, and the reason for that is the decommissioning costs. In the US alone, this value actually is about $300 million a year spent on decommissioning alone. Now, typically for tidal power, the rate is about 7 to 10 cents per kilowatt hour. While it's not the cheapest form of energy, it's definitely getting competitive with the others. So, in conclusion, tidal power is quite economically competitive. It's a clean and renewable form of energy. However, its only drawback is that it's highly dependent on its geography location. For example, British Columbia would never be able to support their entire power grid from tidal power alone. There are very few locations where the currents here are strong enough to make any useful power. However, I would recommend that any place that can use tidal power should use it, for it's clean, it's reliable, and that basically draws the end of my presentation, and I hope you've enjoyed it. Thank you for listening.